In the last couple of videos, we talked about making confidence intervals for the population mean, and to do that, we used our x-bar value. We had x-bar plus or minus. We had our z-value, or our t-value in some instances, of alpha over 2, and then we multiplied that by the standard deviation of those sample means. In this video, we're going to be covering the confidence intervals for population proportion. So we're talking about the population proportion is p, where the sample proportion is p hat. However, if you think about what the proportion is, especially a sample proportion, the sample proportion is the average number of successes in n given trials. So because of that, because it's actually a mean number of successes, we can use our same formula again. So instead of having x bar, we have our p hat value, and we add and subtract our z of alpha over 2 using that same normally distributed value, and then we just multiply it by our standard deviation of, instead of our x bar, it's of our p hat. Since our sample standard deviation for our p hat values is a slightly different formula, we'll just write it out here. So we have p hat plus or minus the appropriate number of standard deviations of z of alpha divided by 2 times what our formula is for sigma sub p hat, which is the square root of p times q, and that over n. So n is inside that square root symbol as well. So we have p hat plus or minus z of alpha over 2 times the quantity of p times q divided by n, and that whole value taken to the square root. So let's walk through an example of finding a confidence interval for a population proportion. So we're going to flip a coin 100 times, so n equals 100. And of those times, we get the number of heads. Heads is equal to, we get 48 heads, which makes our p hat of 48 divided by 100, or 0.48. And then we're going to try to find a 99% confidence interval, which means our alpha is 0.01. So our alpha divided by 2 is 0.005. So we get z of 0.005 is equal to 2.576 standard deviations. So to find our confidence interval, we have our p hat value, p hat, plus or minus, we have our z, alpha over 2, times our sample standard deviation, s sub p hat. So we get p hat is 0.48, plus or minus our z value of 2.576, and that is multiplied by s of p hat, which is equal to the square root of p hat times q hat over n. So we get 0.48 plus or minus 2.576 times the square root of p times q, or 0.48 times 0.52 is 0.2496 over 100. And we get from that 0.48 plus or minus 2.576 times the quantity of basically 0.05, and then we get 0.48 for our confidence interval, plus or minus 2.576 times 0.05, we get 0.1288, which makes our confidence interval 0.3512 up through 6.6088. So we're 99% confident that our p-value, or the true proportion, is within that interval of 0.35 up through 0.60.